So, we are going to discuss material selection for design activity. It is very important to select the right material for a given product. Now, the criteria for selection are listed here. The first one is performance, that the material must be able to suit the performance criteria laid out in the needs of a particular product. So, the material should be able to meet the performance level. The second is efficient manufacturability, that the material should be such that we should be able to process it efficiently on the machines. It should not create too much problem in processing. In that case, there could be a lot of waste of material, there will be a lot of difficulty in managing the process, and a lot of defects also will be produced. And therefore, manufacturability of the material is also an important criteria. Then comes reliability, that is performance reliability is also very, very important, that there has to be some extent of reliability with respect to the level of performance that we expect from that particular material. The next that comes is degradability. Because of this today environmental issues which we are facing now, the degradability of the material is also very, very important. The next one is recyclability, that is also related to the environmental problems or issues. So, recyclable materials are to be preferred. So, you have to also see whether the material is recyclable at all or not. The last one is compatibility, that is whether the material, sometimes we have to use not just single material, but maybe we have to use multiple materials. So, the materials must be compatible to each other. If they are not really compatible to each other, then there could be difficulty in their performance, difficulty in using them together, there could be manufacturing difficulties also, various types of difficulties we may face if they are not compatible to each other. So, these are the basic criteria on which the material selection depends. Therefore, the basis of material search is performance characteristics is the most important, and there we have to also remember that the performance of the material is also dependent on service and environmental conditions under which the material is likely to be used. So, we have to know this, that what is the service conditions and what are the environmental conditions, and therefore, we have to see that the material should be able to meet the requirements in those kind of environmental conditions, like something which has to be used in sub-zero temperatures. We have to see that the material should not get brittle when the temperature goes below 0 degree centigrade. So, something which is quite suitable at a temperature of 20 degree or 25 degree or 30 degree may not be suitable at all when the temperature goes below 0 degree. So, the environmental conditions are different, and therefore, we have to see that the material property that we generally observe in a laboratory situation or laboratory conditions, similar property we may not be able to see when the material is going to, or the product is going to perform in an area where the environmental conditions are completely different from what we see in the laboratory. So, that is very, very important to remember whether while selecting the material. The other one is contribution of the material properties to products functional performance. That is the most important criteria, that is the properties of the material should be such that it should meet the functional performance requirements of the product. And manufacturing easiness we have already discussed. Here we have to see that the condition under which the material is likely to be processed, that we have to keep in mind. What kind of conditions we maintain in the shop floor, what sort of technology we have to process this material, these aspects also need to be kept in mind while choosing. The other one is material attributes also to be influenced by the processing. So, sometimes we have to remember that the processing conditions are such, or we have this kind of machines, and therefore, not necessarily that whatever material suits the performance requirement, those all of them may not be suitable from the point of view of processability. So, these are the aspects we have to understand and study before we choose the material. So, now this particular slide gives you an idea about the various properties of the material. In this case, for our case, the material is fiber. So, there are different aspects of fiber properties. So, here we are giving a list that what are the basic or intrinsic property of the fiber on which the performance depends. So, if we look at this, we see that dimensional parameters is one of them, that is length, fineness, cross-sectional shape or cream. These are the, or whether the fiber is hollow or not, these are the basically dimensional parameters of the fiber. The next comes the mechanical properties of the fiber, where strength is important. With strength, obviously, the elongation also will come, the modulus will also come, the flexibility, the bending rigidity of the fiber, the toughness of the fiber, which is basically represented by work of rupture, the resiliency of the fiber, how elastic the material is. Then comes moisture regain, whether the material absorb moisture or not, the frictional property of the fiber, the heat resistance, that is the thermal property of the fiber, what is the temperature at which the material is going to melt or it is going to soften. These properties are important, whether it is combustible or not. Similarly, the chemical resistance is another important property, because the environmental conditions could be such that it has to be used under an acidic medium or an alkaline medium. So, we have to also see what is the chemical resistance of the material against so many different types of chemicals with which the material or the product may come into contact. Then the static propensity also could be important in some situations. So, typically these are the properties on which the performance will depend. Therefore, we must have a data bank of properties related to all these and keep it for use for different types of fibers that we have. Then comes the characteristics from the point of view of manufacturability. Now, here again from the manufacturing point of view, what is important is heat resistance, because we know sometimes the material while being processed, the machines can get heated up because of a lot of friction. So, what is the level of the thermal insulation value of the fibers, or how much temperature it can resist, this is important. Length and fineness also becomes important for the point of view of manufacturability. Strength obviously is important, fibers should not rupture, therefore, strength and brittleness, they are important. Flexibility also important, because many a times we have to bend the fibers or twist the fibers while being processed, and therefore, they have to be flexible enough. Then come resiliency, that they are processed, there will be a lot of stresses which will be acting on them, and that may change the dimension of the fibers. So, they should be able to come back to the original dimensions. Resiliency is important. Then moisture regain, interfiber friction and fiber to metal frictions, these are the relevant property from the point of view of manufacturability. So, therefore, ease of manufacture depends on processing conditions like temperature, humidity, speed, settings, etc. And we have to see that fiber characteristics must suit the technology to be used for manufacturing. That we have to keep in mind, that whatever fibers comes to our mind, keeping in mind the performance criteria, from there then we have to see what is the manufacturability of the fibers, how easy it is to process the fibers on different types of machines. So, material selection process, if we want to show in the form of a flow chart, we can say that first we choose any product performance parameter. See, sometimes the performance of a product, there may be not just one attribute, there may be multiple attributes of a product from the point of view of performance. So, first we will choose any one parameter related to the performance, then identify the material property with absolute lower and upper limit for the applications. Then you choose the property that the material without giving name of the material, that if it is strength, what is the basic minimum strength that is required, that is the absolute lower limit, so that it can meet the requirement of strength of the product, or it could be some other, no, not necessarily strength, it could be something else also. So, we have to know what is the upper limit and what could be the lower limit. Then consult the database and identify few material candidates that can possibly meet the specifications. Then we must prepare a proper database of properties of different fibers, natural fibers, synthetic fibers, high performance fibers. So, whatever new fibers are coming, all those fibers we should maintain a database of their properties. Now, once we from the database we choose some candidates, then maybe sometime we will find not just one, maybe there are 3-4 fibers which will meet the criteria. Then repeat this for another performance parameter. So, we say for performance parameter 1 x, y, z, there are 3 fibers. Then we go to the performance parameter 2 and again see how many fibers could be there which will be able to meet this criteria. So, this way we make a list of material that suit different performance characteristics and then choose the one or more than one that are common in the list. After that, make a final selection on the basis of manufacturability and cost, because cost is also very important and the fibers should be easily processable. So, this is the typical flow chart which one can follow. The other selection guidelines are, normally we should remember that usually strong and flexible fibers perform well in manufacturing. The other one is the properties of the selected material in fabricated state may be different from its isolated state. That also we should keep in mind, that whatever property that we observe when the material is tested in an isolated state in a laboratory conditions, and where they are in the form of groups or they are interacting with another type of fibers, then the same performance or same property of the fiber may not be reflected totally when these fibers are in the form of groups or the fiber is in contact with other fibers. So, that this aspect we have to always keep it in mind. Microdenier fibers, like say, they are very good from the point of view of in the case of apparel products, because they give very good drape, they make a fabric very flexible, and they are also very good for filtration purpose, because it can create very fine pores. So, for wipe and cleaning they are generally used also. However, it poses some manufacturing challenges like nap formation in carding, or they can get easily damaged, because being very fine they are very weak also. So, there could be processing difficulty and there is a possibility of damage also while I am trying to process these fibers. So, there are from the property point of view they may be suitable, but from the processing point of view they may not be that suitable, because of nap formation, damage. So, nap formation will spoil the appearance of the fabric. So, these sort of situations may arise, and we have to make a very a choice, keeping in mind all the aspects, performance aspect and the processability aspect. Now, we will take an example. Let us say we have to design a car seat belt. Static load bearing capacity is 2272 kg force, and the belt width has to be 35 mm, and belt weight is 60 gram per meter, which is 60 kilotex. Now, if the other criteria is belt extension should be 25 to 30%. Now, if this is what is desired in the product, then we have to, let us say, try to find out which fiber really suits, or how many fibers we can identify. So, from the point of view of performance parameter 1, we have made a very simple calculation for an initial estimations, say strength and extension. So, the belt strength has been given, this is the required strength. From there, if we can work it out, what is going to be the strength or the tenacity of the belt in terms of gram per tex or gram per denier. So, we divide the strength, convert them into gram, and then divided by the weight, and we can find out, say, this is what is actually should be the denier, gram per denier or tenacity of the belt. Now, if this is the tenacity of the belt, the fiber tenacity has to be more than this. This is the requirement. So, you can immediately get an idea that what should be the tenacity of the fibers, and now we can try to find out do you have really a fiber which have a tenacity value greater than this. It should not be equal to or less than this. It has to be always more than this, because the strength translation efficiency from fiber or the filament to the belt can never be 100%. And therefore, it is better that we should go for a tenacity value which is more than 4.2. Similarly, the belt extension should be around 25 to 30%. That means, the fiber extension also has to be at close to this, not less than this. Now, if you look at table 1, which we are now, you can see now that if I give this criteria and you study the fiber data bank where the properties are listed, we can identify these fibers, nylon 6, nylon 6, polyester. As an example I am giving that these are the 3 fibers which meets the criteria that has been stated just now, and therefore, all of them will be suitable for the manufacturing of car seat belt. Next, if I now go for another criteria, that is abrasion resistance, that is the car seat belt must have a good abrasion resistance value. From there, now if we see table 2, abrasion resistance values are not given in terms of numerical figures, but in a qualitative manner they have been stated, because we can consult lot of research papers and find out what are the values, and from there we can have a qualitative ranking of fibers also. That also could be very useful, not necessarily that initially we have to go by the numerical figures of various properties. If we have a table with us where the properties are given in terms of qualitative terms, then also they can be used for as an initial guidance. So, here we see that generally all of them are very good, and therefore, all of them will be suitable from the point of view of abrasion. Now, you use another criteria, resistance to sunlight. This is another criteria that we are imposing on it, because the car may be lying under sun, and hence the sunlight may be falling on the belt, and therefore, the belt should not get damaged by the UV of the sunlight. So, that could be another criteria, and if we see there that the resistance to sunlight, and we will see that polyester has good to excellent behavior, whereas nylons are poor to good. Therefore, from the performance criteria, resistance to light or sunlight in this case, we can say polyester is scoring over nylon. So, that way polyester will be little better. The next one that comes to the mind is the cost part finally. Obviously, we have to see that how much we are going to lose if we choose material A or B or C in terms of its performance, and how much we gain in terms of cost. So, cost will also always be a deciding factor while we decide the right material. Sometimes we may need to mix the material also, not just one material, but we can have a blend of 2 materials, and so that is also possible. So, this is just an example, very simple example. The other aspect is sometime we can go for straightforward selections, that is, in some situations material selection become straightforward process due to limited options available with the appropriate material or well established performance of some material in a particular product. So, an example has been given here, that here the choice becomes almost automatic, like for denim, cotton. this is such an well established raw material for denim that we choose the material immediately, that if I have to go for designing a new denim, a new type of fabric, whatever it is, cotton has to be there as a raw material. Similarly, for towel it is always cotton, it is also such an established product. For wedding sarees, like silk is always, for any ceremonial dress generally silk is preferred and silk is being used for centuries. So, it automatically becomes silk. When for shawl, very fine wool will be the right choice. Now, that today there are other fibers which are being used in shawl, but when it comes to very elegant looking shawl or very high quality shawl, then obviously very fine merino wool will be the right choice, because there is a very good association between these two, the property and the performance over so many years, and therefore, the choice becomes almost automatic in nature. Now, where to search for material? Material database is a good source. So, we have to create a database of material, that is whatever fibers we to use. Not only fiber, we may need other material also, for other than fibers also we may need some adhesive sometimes to join the two fabrics. So, we have to have a database of adhesives also. We have to keep the property of the adhesive, that which adhesive we should use where. Similarly, whatever other accessories that we use for any product, we have to maintain a database of the different material that is used and their properties. So, outcome of the search process is a set of material candidates that have great potential to meet the desired product performance and manufacturing criteria. And therefore, an understanding about materials contribution to product performance is very critical. So, this aspect means if we try to design something, we must have a good understanding between the property of the material and the performance of the product. See, performance and property of the basic element of the product, that is the fibers or maybe yarn, that understanding has to be there, then only it will be easy to understand. Like we have given here the materials contribution to the product performance. As an example, we are writing here on the right hand side fiber parameters are given, on the left hand side product parameters are given. The product is a carpet, on the left hand side the fiber parameters are given here, because we must be able to associate first, that needs real domain knowledge. Like for a carpet, the important properties are compression recovery, bulkiness, insulation, abrasion resistance. I have just given 1, 2, 3, 4 property. Now, if these properties of the product is related to what properties of the fiber? Now, we are giving you a diagram here, and you see the basic property of the fiber are connected to the product properties by, we have joined them by some arrows just to show that they are the relevant fiber properties. Like breaking energy of a fiber, it is important for compression recovery and also for abrasion resistance. Fineness of the fiber is important for compression recovery, for bulkiness, for insulation, for abrasion resistance. Density of the fiber can decide bulkiness, insulation. Resiliency will decide bulkiness and compression recovery. So, these properties are related to the product performance. So, such kind of a diagram one has to make in order to know that this performance is related to this basic properties of the fiber. Therefore, we can choose the right type of fiber. So, that this sort of capability the designer must have. The outcome of the material selections could be, as I just already told, it could be a single material with desirable performance characteristics, and in some cases it could be 2 or more materials that can be mixed to get the desirable characteristics. So, many a times though we blend. So, you are very familiar with polyester cotton blended shirt or polyester viscose blended materials. They are so common because one material does not suit and it does not give us the desirable performance, and therefore, we try to mix 2 different types of fibers. As fibers are converted to different structure, some of their characteristics can get altered in magnitude or relative contribution to the end product properties. That also we need to know, or we need to keep in mind that when they are converted into different structures, some of their characteristics can get altered in magnitude or the relative contribution to the end product properties. This possibility could be there, or we may be able to change some of the characteristics by giving different types of finishings to the final product. We can make certain characteristics to be more visible or some characteristics to remain subdued. This is also possible. That depends upon the processing part of the material, but the fiber also can play a role. Now, just to as an example, let us say we take an example of technical textile products. Technical textile is a very vast field. There are so many types of technical textiles. We all know that they can be classified into different types of technical textiles also, like geotextiles is there or medical textiles. So, similarly, there are many types of technical textiles. In general, the technical textile product, the basic properties are dimensional stability, durability, strength elongation, strength to weight ratio, and their time dependent behavior, safety and comfort. These are the basic property of the technical textile fibers. The functionality could be that it is acid and alkali resistance, UV resistant, stain, water resistant, odor free, dust repellency, flame retardancy, insect repellency, anti-static behavior. They are also part of the functional requirement of the many technical textile products. So, there are some basics which we have to meet, and there are some others which are also very important. So, you can classify them as basics and functionality. Similarly, for apparel products, generally the basics are dimensional stability, durability, comfort, fit, stability, durability, strength elongation, strength weight ratio, all of them are important, and strength weight ratio really not so important in the case of apparel products, but fashion, aesthetics, maintenance, safety, these are really very important. Functionality point of view, stain and alkali resistance, UV resistance, stain, water resistance, these are all important, that we should not get even watermark on the apparel product, like on silk saree. it is common that if we try to wash a part of the silk by water, there will be, if the water dries, we will get a watermark. So, that spoil the appearance of the silk. So, simple no, this could be a problem also, because generally these are very costly products. So, the appearance gets spoiled because of any kind of stain, not only from chemicals or even from water also stains could be there. Similarly, sometimes it should be water resistance depending upon the type of apparels we use it, odor free, UV resistance, flame retardancy, anti-static behavior, all of them are important for apparels, and one can add more or one can cut some of them depending upon what is the apparel that we are discussing. So, this is in general. If we take a specific apparel, then we can make another list, what are the basic properties we expect in it and what are the other functional properties that we may need. Like as an example, we are giving it the comparison of performance characteristics of different carpet fibers. So, let us say there are 4 fibers here, wool, polyester, polypropylene, nylon. These fibers are mostly used in carpet, and a qualitative data in relation to their performance, that is resilience, appearance, retention, abrasion resistance and sunlight resistance, they are stated here in this table. So, there are basically qualitative values in terms of excellent, good, fair, poor, like that. So, you see that these fibers, whatever the list shows it here, every fiber has some good points and there are some points where they are inferior in comparison to the other. So, what we see that we get carpets today made from wool fibers, polypropylene fibers, nylon, polyester, all types of are available. Each of them have their own merits and demerits, or sometimes we can mix them together also to get certain properties which we expect in them. So, this kind of table can help us in really choosing the right material. With this, we close this particular discussion. I hope that if you keep in mind these aspects, it will be easy for you to make the initial selection process of fibers, and then one has to go for in more detailing obviously. So, you know then how to reject some fibers from the huge different types of fibers that we have with us today. Okay? Thank you.